Assalamualaikum warahmatullahi wabarakatuh and good day to all of you. So my name is Azazi. So this is our first lecture of hydraulic and pneumatic technology, Bmmm2333. Okay, and the first topic is introduction to fluid power. Okay, here is the outline of this first lecture. Number 1, introduction to fluid power. Number 2, hydraulic and pneumatic symbols. Number 3, application of fluid power. Number 4, properties of hydraulic and pneumatic fluids. Okay, next, what is fluid power technology? Okay, it is a technology that deals with generation, control and transmission of power using fluid, and there are two types of fluid power. First is hydraulic and uses liquid as power transmission media, and from a Greek word hydra for power and holus for a pipe. And the second one is pneumatic and gas as power transmission media, and from a Greek is pneum for wind or breath. Okay, this slide showing an examples of fluid power. So by middle of 19th century, fluid power started playing an important role in both the industrial and civil field where electrical energy had not been developed. Okay, water to turn water wheel and air to turn windmill and propel ships. So fluid power used to drive crane, press, winches, extruding machine, jack and other various machines. Steam engine drove hydraulic pump to deliver pressurized water to powering hydraulic machine. So modern era of fluid power is considered began in 1906 when a hydraulic steam used to control guns on the battleship USS Virginia. Okay, initially water also used for fluid power application, but because of its limitation such as easily to freeze or corrode metal, and today most hydraulic system use oil as the fluid. Here is the two laws that related to fluid power. First is Pascal law and the second is Bernoulli principle. So Pascal law, or the principle of transmission of fluid power, is a principle in fluid mechanics given by Blaise Pascal that state that a pressure change at any point in a confined incompressible fluid is transmitted throughout the fluid such that the same change occur everywhere. Okay, and the second, Bernoulli principle, state that an increase in speed of fluid occurs simultaneously with a decrease in static pressure or decrease in fluid's potential energy. Okay. This slide showing the advantages and disadvantages of fluid power. Okay, first advantages is easy and accuracy of control. So by only one simple levers and button, the operator can start, stop, speed up or slow down and position the system easily. Second, multiplication of force. So simply multiply an ounce input force to several hundred tons output force by increasing actuator area or working pressure. Third, constant force or torque. High power to weight ratio and high power to volume ratio are readily achievable regardless of speed changes because torque and forces generated by actuators are limited only one pressure. And the last advantage is simplicity, safety and economy. where it uses fewer moving parts compared to mechanical or electrical system. Okay, for the advantages, first is leak and messy. So the hydraulic fluid such as oil or water may leakage from hose, connector or reservoir that impossible to be eliminated completely. An improper pneumatic air tank and accumulator may reduce the efficiency of system. The second is the safety. Improper design might cause hydraulic line to be burst and resulting human injuries due to flying object. So the hydraulic oil can cause fire if leak occurs in an area of hot equipment. So in pneumatic system, the air storage tank and accumulator have potential to be exploded. And the last advantage is noise. Pump and compressor may have noise during operation. So next, power system are used to transmit and control power, and the basic parts of power systems are source of energy, which is electric motor, internal combustion engine, steam turbine, gas turbine and hydraulic turbines. And the second, energy transmission, transformation and control element. And the third is the load that require a mechanical power, either a rotary or linear motion. Okay, next is the branches of power system. So in power system, there are three types, which is mechanical, fluid and electrical. So under fluid power system, it divided into hydraulic and pneumatic, and under hydraulic it divided into hydrostatic and hydrodynamic. So hydrostatic is the study of fluid at rest, and hydrodynamic is the study of fluid in motion, and it uses kinetic energy. Okay, here are the difference between liquid and gases in fluid power. So under liquid, fluid that have a definite volume for a given mass, and volume will not vary to fill its container, and considered incompressible because change in volume due to pressure changes is so small that can be ignored. Okay, for gases, fluid that for a given mass will increase its volume to fulfill its container, and fluid that readily compressible and increase of pressure causes decrease of value and vice versa. Okay, air in the only gases in fluid power system. Okay, and next, okay, this is the component of hydraulic power system. There are 6 components. Okay, first is a tank or reservoir. The purpose is to hold the hydraulic oil. Next is a pump to force the oil flow through the system. Third is a power source to drive the pump, example of electric motor. The next is valve. Purpose is to control oil direction, oil pressure and flow rates. Next is actuator to convert the hydraulic pressure to mechanical force and or torque to useful work. And last, pipe or hoses to carry the oil from the one location to another. Okay, next, this is the arrangement of hydraulic component. Okay, this is a reservoir. Next is a electric motor. This is pump, pressure relief valve, directional valve, flow control valve, check valve and actuator. Okay, and this is the basic component for rotary hydraulic motor. Okay, reservoir, pump, valve and motor. Okay, next is a component of pneumatic power system. Okay, same as hydraulic system. So it consists of a tank or reservoir, a compressor to compress the air, a power source, valve actuator, pipe or hoses. Okay, next is the symbol for fluid power. So this is the examples of hydraulic component. So here is a symbol for tank, pump, cylinder, hydraulic motor, multi-way directional valve, flow meter, manometer, pressure valve, and one-way directional valve or check valve. Okay, and here is the symbol for basic pneumatic components. Okay, tank, compressor, cylinder, pneumatic motor, multi-way directional valve, flow meter, manometer, pressure valve, and check valve. Okay, so this is the fluid power application. There are many applications can be applied by using fluid power. For example, is mechanical handling, industrial motor, machine tools and automation, injection molding, hydraulic press and other workshop tools, mobile hydraulic, marine, vehicle, aircraft, mining and agricultural. Okay, last slide showing the typical properties used in fluid power. Okay, this is the examples of properties: mass, weight, volume, specific weight, specific gravity, density, bulk modulus, dynamic viscosity and kinematic viscosity. And here is the symbol or the description, and this is the unit of the properties. Okay, and thank you.